lines. First topic is we want to determine whether or not two lines are going to be parallel. Parallel lines never cross. They never intersect each other. They have no points in common. If we're looking at a graph, that's pretty easy to see whether or not two lines are going to cross sooner or later. If they're parallel, they're gonna run right next to each other like a pair of railroad tracks ties. The tracks themselves, the metal tracks, they don't cross each other. If we're looking at the equations though, which oftentimes we're just going to start with the equations, we need to look at the equations and determine, do the equations have the same slope but different y-intercepts? If they do, then that's going to help us decide that we have parallel lines. Parallel lines have the same slope, so they're increasing or decreasing at the same rate. The reason they have to have different y-intercepts is because if we had the same slope and the same y-intercepts, we'd have exactly the same lines. And when we graphed them, they'd run right on top of each other, so they wouldn't be parallel. So let's start by looking at the equations for the black lines. Let's see, I'll use some orange here. If I'm looking at these two equations and I want to compare their slopes, hey, look at there. Those two equations have exactly the same slope. A lot of times students will say, oh, yep, same slope, these two must be parallel. And sometimes I do the same thing myself and I have to remember, yeah, but we also have to check the y-intercepts. As long as the y-intercepts are different, then we're in good shape and we would have parallel lines. Now the y-intercepts here, one's a +3, one's a -3. Those values are not exactly the same, so that tells me that yes, these lines are parallel. Okay, so parallel lines. Okay, now let's compare the next two. Ooh, interesting. This equation says y equals 1/2 x plus 2. This equation says -5x plus 2y equals 14. A lot of students will look at that and say, this has a slope of -5. This has a slope of 1/2 because those are our numbers in front of x. And they'd say, nope, these aren't parallel. Well, in order to compare the slopes, you first have to have both equations in the same form. This equation is in what we call slope-intercept form. This equation is in standard form. It's kind of like comparing apples to oranges. It doesn't get us anywhere. We have to be able to compare apples to apples. We have to compare things that are the same. So before we can determine whether or not these two lines have the same slope, this equation has to look like the first one, and we need to get y alone. So in order to get y alone, I have to manipulate these equations and move things around. I'm going to add 5x to both sides. Now I can't really add 5x to 14 because those are not like terms. They're not the same. I have 5x plus 14. And to get y alone, I'm going to have to divide by 2 because it's being multiplied by 2. I want to make sure I divide everything by 2. Y equals 5/2 x plus 7. Now when I look at the slopes, I've got a slope in this line of 1/2 and a slope of this line of being 5/2. Slopes are not the same. These lines are not parallel. They would cross each other somewhere if we were to graph them. Okay, now we do the same thing for the next two equations. The first equation, we've got 3x plus y equals 9. If I want to get y alone there, I'm going to have to do some changing, some manipulating. And if I move the 3x over to the right, I want to subtract it because it's positive already on the left. Y equals -3x plus 9. So this line happens to have a slope of -3. Second equation, 3y minus x equals 12. Well, I got to add x. 3y equals x plus 12. You might want to compare already, but you can't. Y is not alone. Y is being multiplied by 3. So we got to undo that and divide by 3. Y equals x divided by 3. Now, some people would say, oh, that's 3x. No, really it's not because there's a 1 on the top next to that x. So really it's 1/3 x plus 4. 12 divided by 3 is 4. So when I look at this, I've got a 1/3 right here. and a -3 up here. These two lines do not have the same slope. These would not be parallel. Okay? Now the last two, I have them already in the form of y equals. This has a slope of 1/3. This one has a slope of 1/3. So when I compare their slopes are the same. But remember, we need to have different y-intercepts. And when I look at these y-intercepts, I see y-intercepts of +2. So that tells me if I go to graph these lines, they would be the exact same line. They would lie one on top of the other. These are not parallel.